You answer. All right, so that is running of time for you guys to get in with you all on it.
Nowhere, sir.
Nice, 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 nice. Well, trusting and hoping that all is well with everybody else. We have important things to cover tonight. I'm just trying, but also I'm going to be teaching tonight as well, because we have a lot to cover.
Sir, could you repeat that, sir? I'm not listening.
And I'm just saying we have a lot to cover, so I will be teaching tonight nonetheless. So I'm going to teach and then break, so that we can do the mid-semester, and then I'll break. I'll be closer to the end of the class. So when they finish, you can just leave. But so Sash was trying to engage either me or the class in a conversation that she feel like she's ready to go with the stuff, and I was saying to her to shoot, but it's like she never used to play netball, so she don't know how to shoot a ball.
So, negative.
You used to play netball?
Yes, sir.
Wow, nice. So, all right. So, how you stay with the question?
Sir, I'm stuck. I sent a message in the WhatsApp group, sir, to say I would need some, I want you to go in depth to that question, because kind of still,
Oh, okay. Not a problem. So did you respond to my message when I said to you to shoot?
I in class a while ago.
No. In the you had said something in the group. Was it in the group? I'm sure I responded to you with something that you said, you feel like you're ready to go, something like so. Is you or somebody else?
I don't know, sir.
Oh, who was it? Somebody said it. Let me just double check. I wonder if I get mixed up. Three say you have plans when you buy the car and we get excited. I wonder if I got told Jesus. I like close up on it. Yeah, I know you say it, man. I'd like to close up on the question that we did last night. I mean, it's a nice shoot. I mean, you're not more from you.
Oh. Okay, sir.
You see what I talk about?
Yeah.
All right. Okay. All right. Never mind. That's fine. Let me ask a question though. What about the rest of you? Were you able to get? That's a big question. Let me ask. You see what I was talking about as it relates to the question can get a little rough.
Yes, sir.
And I had to build your confidence first before I drop a question like that, because I did say to you that the question or the topic is not difficult. Are you hearing me fine?
No, no, clear.
Yes, sir.
Okay, good. Yeah, man. So there can be some functions that you get some, some types of equations that can really throw you out in terms of the simultaneous. I don't expect one of those for the final paper, but I'm saying to you that if it comes, don't be alarmed. You should be able to manipulate the question and do pretty well at it. All right, so what I'm going to do is I'm going to walk you through the process. This slow code to China is trying to download the document. Give me half a second. Let me just see if I can get some energy drink. Hold on. Computer.
Remind me what this topic is called.
Multivariable functions. Got me?
Yes, sir.
Yeah, so it's multivariable functions, but I'm looking at stationary points of a multivariable function. Stationary points of a multivariable function. All right, I'm just trying to find my solution to the question. I think it's important for me to go through one of these questions with you. What is also important, students, please, is to go through the other questions within the past paper. If it means that you have to go through it and then it's a boy, sir, before we move in, you can work for one question with me, please. I have no problem. I've been more than willing to do it, and I'm going to tell you why. Sometimes questions repeat. That's all I'm saying to you, Sometimes questions repeat. So if you are going to be doing, and you can see something for, and I'm not, it's not an indictment on CCCJ. What caused me to survive through UII is me getting past paper questions or past papers and just start working. Trust me. Especially some of those courses that me never did like. Sorry. Some of those courses that did not like me. Me get the paper. I'm gonna say, Lord Jesus, I'm gonna research the questions. And sometimes the questions don't come out verbatim, but the research that I would have completed would have given me enough information so that I could reproduce it on another exam paper. So it's very important that you attempt as many past paper questions as you possibly can. All right, so I'm sharing the screen. So it says a small startup company produces speakers and subwoofers for computers that they sell through a website. After extensive research, the company has developed a profit function. Pi of xy is equal to x squared y minus 22xy plus xy squared plus 71 in thousands of dollars. we need to find the production levels that minimizes the profit. So what I'm saying to you is the mere fact that the question says a production level that minimizes the profit. When you go ahead and find it in your stationary point formula, D is going to be equal to f of x times f of y minus f of xy all squares. It means that D is going to be positive. So how do you know? Because the question says it minimizes. So D has to be positive. If D is negative, it means that it's a starting point. What means? All right. So, and then now, in addition to that, the value of f of x has to be positive. Since it's a minimum, it has to be positive. So in your headspace while you're working the question, these are some of the things that you need to work on. So if when you evaluate f of x and you get it to be negative, sitting wrong, don't even go any further in the question. I promise you. It says find the production levels that minimize profit. The formulation says if f of x is negative, I'm going to have a relative maximum. But the question never says find the production level that maximizes profit. It says find the production level that minimizes profit. So f of x has to be positive. So if when I'm working this stuff and I get something be negative, I have to go back and check if something is not right. And you recognize that this question carried 30 marks. Don't play with a 30 marker. A 30 marker is enough marks. If the paper is marked out of 60, and you can do a question for 30 marks and get full marks for that, you're on your way in passing, you pass the course. All right, so let's go. The first thing to do, even if you don't understand what the write-up is saying, similar to what Calculus 1 gave you in terms of a lot of write-up, you have a multivariable function. Go ahead, and there are 6 things that you must find. Fx, xy, fxx, xy, f subscript y of xy, f subscript yy of xy, f subscript xy of xy, and f subscript yx of xy. Do those 6 calculations. Once you do those 6 calculations, you're good to go. And remember, to find stationary points, dy by dx must be equal to 0. So your f subscript x and your f subscript y are your 2 first differential. Remember, you have only one variable as a subscript. So that's the first differential. The others are second differential. X is a second differential with respect to x. Y is a second differential with respect to y. And xy and yx are the cross partial differentiations. All right? So once you do those 6 calculations, you get at least 6 marks. Could be more, but you get at least 6 marks. Then the next thing to do, set their first differentials equals to 0. So let us differentiate x squared y. Let us differentiate the function with respect to x. Differentiating with respect to x, I'm keeping my y constant. This is married, so I can't throw out my y, so I'm going to keep it constant. The differential of x squared is 2x. So my first term becomes 2xy. The second term is also married. They're also married. So I'm going to be differentiating with respect to x and keeping my y constant. The differential of negative 22x is negative 22. So the other term becomes negative 22y. The third term is also married. Y squared is constant. I differentiate my x. Differential of x is 1. So I'm just going to have y squared. And the differential of a constant every single time, today and tomorrow and always, will be equal to 0. All right? So what I'm going to be getting is, as I said before, 2xy minus 22y plus y squared. Now let us differentiate the function with respect to y. Differentiating with respect to y, come on. Differentiating with respect to y. I'm keeping my x constant. These terms are married, so I can't throw out anything. So it's going to be x squared as the constant. Then I'm going to differentiate y. The differential of y is 1, so I'm just going to have x squared. See it right here, so? My negative 22 is constant. When I differentiate y, I get 1, so it becomes negative 22x. See it right here, so? When I differentiate y squared, I'm going to get 2y. So this will become 2xy. See it right here, so? And the differential of a constant is equal to 0. Let me differentiate this here with respect to y. I'm differentiating pi of x with respect to y in order to give me pi of xy. Differentiating this respect to y, it's y I'm differentiating with respect to. So that means the other variable is constant. So it means 2x is constant. So I'm going to be writing back my 2x and then differentiating y to give 1. 1 times 2x is 2x. 1 times 2x is 2x. See the 2x right here, so? Differentiating this again with respect to y. Differential of negative 22y is going to be negative 22. See it right here, so? And the differential of y squared with respect to y is going to be 2y. See it right here, so? Then I'm going to differentiate this pi subscript y with respect to x. That means my y is a constant. This goes to 0. No, I'm differentiating with respect to x. That means my y is a constant. So this is going to be 2 times x is going to be 2x. See it right here, so? And I'm differentiating this with respect to x. So this negative 22 right here, so? Differentiating this with respect to x, it means that my y is a constant. Differential of 2x is 2, so I have 2y. And then you recognize that these two are the same. So guess what? It's because these two things are the same, it suggests to me that my pi subscript x and my pi subscript y are correct. If I'd gotten two of these things different, it means that something would have been wrong with either this one or this one. So now I can go ahead and do my x. Differentiating this with respect to x is going to be 2y. Bam, done. Differentiating this with respect to y, 2x, done. All right. Now, so sir, can you tell if f of x is positive here? So I cannot tell you if f of x is positive because f of x did not come out as a whole number. You remember some of the other questions we did look at a whole number? I cannot tell you if it's going to be positive or negative at this stage. All right. Until I find my critical value of y. When I find my critical value of y, I will then be able to tell you what is the color of f of x. All right. So I'm going to go now, solving simultaneously. The one in blue are my two equations that I'm interested in. Are you understanding so far?
Yes, sir.
All right. Oh, come on. Are you seeing a black screen in front of the system?
A yellow square.
Okay, good. I was developing something on Lord. Where was I? Oh, I know where it's going. All right. You know what? I'm not going to say it. I'm not going to say it. I'm not going to say it. I'm going to leave it alone. I got a response, so let me go. All right. So I'm solving simultaneously. So it's going to be 2xy minus 22y plus y squared. And then I'm going to have x squared minus 22x plus 2xy. Yes. So I have two nonlinear equations. I know I have to do a substitution. So I'm going to either solve for x or solve for y and substitute it into the other equation. So if I use equation 1, I'm going to solve equation 1 for x or for y and substitute that result into equation 2. I cannot substitute it into equation 1. So if I use equation 2 for x or y, I must substitute it now in equation 1. All right. So let me do what it is that I did. I worked with equation 1. So I'm using equation 1. So I am using equation 1. So watch what I did. I am saying I'm adding 22y minus y squared to both sides. I'm adding 22y minus squared to both sides to leave 2xy alone on the left-hand side. Can everybody see how I got that line here?
Yes, sir.
All right,
Yes.
good. Nice. So sir, why do you have to do that? So you couldn't just work with the 22. I could work with anything I want to work with as long as I'm going to either get x to be the subject for the formula or y to be the subject for the formula. All right. I chose to use this one. Sir, that means we could have used another one? Absolutely. Absolutely. So I'm leaving my xy on this side. And then I'm going to add 22y to both sides. I'm going to add negative y squares to both sides. So I'm going to end up with this. And then now remember, I want x to be the subject for the formula. I want x to be the subject of the formula. So what I'm going to do is divide both sides by 2y. I don't care where it come out to be. I just want x alone to be on one side. So when I divide both sides by 2y, the 2y's cancel. So I'm left with x. Then I'm going to have, see the 2y down here, so I'm going to have 22y minus y squared. Now, as I said in class, last time around, when I met you for the first time, I was giving you something to do, some limit, something to do. And I heard something illegal. Sir, just cancel out. And I said, no, you can't cancel either a negative sign or a positive sign or a division sign. Only can be done when you are multiplying, where the terms cancel out. So what I have to do is to say what is common here, that is common there. And I recognize that my y's are common, so I'm factoring out the y. When I factor out the y, I'm going to have 22 minus y left. 22 minus y. Now I'm able to factorize. Now I'm able to factorize. Please note that cancellation was not possible for factoring the y's. I had to factor my y's first. Please, students, please. It's a must-have. It can't go to good foolishness. All right, let's go. So when I do that, my y's cancel, so I'm going to have x is equals to 22 minus y over 2. Then, sir, you can have a fraction where it is that again substituting into the stuff. Absolutely. Oh, absolutely. So because I work with because I work with equation 1, I now must have to substitute it in equation 2. So you can't use one, you sure? Positive. It must now be substituted in the other equation. Must now be substituted into the other equation. Very important. All right, so I'm going to put 3 into 2. So 3, yes, sir? So anywhere in equation 2, I see x, I'm going to put all of 22 minus y over 2. Every time I see that. Then, sir, we can't, why we never just write 11 minus y over 2? No, because I'm going to show you something nice that happens. You see, once you substitute that fraction in the function, you just multiply throughout the equation by the denominator to get rid of the fraction. So you don't have to be working with the fraction for way too long. No, you don't have to work with the fraction way too long. Eliminate it first go to get rid of it. All right, and how do you get rid of it? You're going to be multiplying by the lowest common multiple. The lowest common multiple. All right, so Anywhere in equation 2, I see x, I put all of 22 minus y squared. Recall, this is my equation. That's my second equation. So anywhere in it, I see x, I'm going to put 22 minus y all squares. See x here, so what is x squared? So it now becomes 22 minus y over 2 squares. See it right here, so? No biggie. Minus 22 times x. Okay, so this is going to be minus 22 times all of this. See it right here, so? No biggie right here, so? Minus 2xy. 2, and all of this is x. And see y right here, so equals 0. Not a biggie at all. But we'll now recognize that we have 22 minus y over 2 that we need to square. So when we square in a fraction, best believe that it's both the numerator that is squared as well as for the denominator. When you are squaring a rational function, it's both numerator and denominator that you're squaring, not just the numerator, or worst case scenario, the denominator. It's both the numerator and denominator. Because what I could have written is 22 minus x, 22 minus y all squared over 2 raised to the second power. But I just combine it and just write 1 power. Are you following me?
Sir,
Yes, son.
I'm confused right at the recall.
Sir,
Mm-hmm.
just coming to class, the machine crashed by me. I never caught any of it.
All right, never mind. All right, so I hear from ABC. I hear from Stash. Anybody else?
Sir, I'd like you to go back up a little bit and where you have the 2y. No, further up. Right there, the equation I to give. So you have 2xy equal 22y minus y square. And then down here now you have 2y. Where did this 2y come from? Is factor is
This 2y?
Yeah.
Yeah, actually.
Mint, look at it now, honey.
Wow, you call me honey.
Hey!
That's the first.
You know why? It's the first thing on mute and I talked to me for so long. Talk truth. I said to myself, well, look how she's so decent. Jesus. Nice one. Nice. But yes, hon, go ahead. You see what I get the 2y now, hon?
Yes.
Yeah, man. So I want x to be the subject of my formula. So anything that is around the x is what I'm going to divide by because I want to cancel it out from this left-hand side.
Okay, thank you.
You sure you see it?
Yes, sir.
All right. Rasha, I hear you coming in something when you say something.
Yeah, I'm not gonna tell her, sir, because you don't try make x a subject.
Got you. Very nice. Proud of you. Nice. Okay. Sash, you say confused right here, so?
No, the right there.
Okay.
Because I don't see the negative 22 plus 2 in the second line. No, the other line.
This one?
Right, yes.
All right. I have it down here. So what I was doing was expanding up here. So all right. So maybe what I should have done, and I'll fix it for you. It's just how we learn. So no, that's supposed to be 2 squares. It's all right. When I write it, you can say, "Oh, that's sir." I'm gonna say, "Yeah, that. Not a problem, honey." By the way, Wind, I need to side talk with you after. Well, I'm going to side talk with you at some point in time in the chat. All right. So you see what I have here, Sash? 22 minus y over 2. I'm saying to you is the same thing as 22 minus y squared over 2 squared. So this 2 here governs both numerator and denominator. That's the point I was trying to make.
Yeah.
And then 22 minus y all squares is 22 minus y times 22 minus y. And 2, let me just put this as 2 times 2.
Okay.
Can you say the seat? You see it now, right?
I see that part, but what about negative 22 with the other fractions?
This one here?
Yeah.
Yeah, I don't, this one is easy to distribute. These are easy to distribute, you know, because this one is raised to the second power.
So you're doing it segment by segment?
Yeah.
Okay.
All right. So I'm just expanding this one to show you what it is. So this 22 minus y, all squares, is 22 minus y times 22 minus y. And this 2 squares is going to be 2 times 2. 22 times 22 is 484. 22 times negative y is negative 22y. Negative y times 22 is negative 22y. And negative y times negative y is positive y squared. And 2 times 2 is 4. 484 is the only whole number. So I write it back. Negative 22y minus negative 22y, or minus 22y, is going to be negative 44y. And y squared is a standalone, so I put it back. So is my 4 in the denominator, so I put it back. So therefore, my first term in the expansion or simplification of this thing here is going to be 484 minus 44y plus y squared minus 4.
Over 4.
Over 4. Thank you, Papa. Now look at what I'm doing here, Sash. It's negative 22. Go ahead, Rash.
Oh, sorry. I base me that look on a while ago and me that say mine tell me say that go on.
So look at what is happening here now. You see. Where's Nesta? Nesta not. Has anybody spoken to Nesta recently?
Next time, they care to answer.
Next time I can talk.
So hold on, let me just sip a little tea right here. So all right, so if you look at this here now, what we're going to have is this negative 22 is going to only control the numerator, not the denominator. Please let me put something here to show you that 22 is only controlling the numerator and not the denominator. Very important. The numerator and not the denominator. Good. All right. So I'm going to have now, because this is being multiplied by this, I can cancel this 2 into this 22 to give me negative 11. So that's why I have this negative 11 right here. And this negative 11 is going to be multiplied by this 22 minus y right here. Right there. So similarly, this 2 cancels into this 2. And it's going to give me just 22 minus y times, of course, this y on the outside here, which is right here. And as I said before, I am multiplying through the equation by 4. Why 4, sir? Because the LCM here is 4. The LCM throughout the question is 4. So I'm multiplying through by the LCM. When I multiply through by the LCM, I'm going to get rid of the fractions or my denominator. So watch me. 4 times all of this is going to just give me 484 minus 44y plus y squared. See right here, sir? Because the 4's cancel out. The 4 you're going to cancel out with that 4 here. So I'm left with all of this. And 4 times negative all of this is going to be 4 times negative 4 times all of that. And 4 times 22 minus y is going to be 4 times 22 minus y. All right? Similarly, I'm going to now distribute. I'm still keeping this negative 4 outside here because I have something inside the parentheses to work on first. 11 times 22 is 242. And 11 times negative y is going to be negative 11y. Similarly, 22 times y is 22y. And negative y times y is negative y squared. So now I can distribute these 4s over the parentheses. All of this is written back. Negative 4 times 242 is negative 968. Negative 4 times negative 11y is positive 44y. 4 times 22y is going to be 88y. 4 times negative y squares is negative 4y squares. And that is equal to 0. If I put all the like terms together, I'm going to have, which will be all the negative 44y cancel is positive 44y. See right here, sir? So them two will cancel. So this line should actually come right here, sir. To give me negative 484 minus 968 plus 88y plus y squared minus 4y squared. And then 484 minus 968 is going to be negative 484. This 88y stands alone, so it comes back down here. But negative 4y squares plus y squares are negative 3y squares. Similar to how I multiply through that equation by 4 up top here, I can multiply this equation down here by negative 1. So why?
Why?
Good. Thanks for asking. Because my y squared is a negative value, and I don't want to factorize it a negative value. So I want my y squared to be positive. Then so you can factorize it a negative value, yeah. Me can do it without making a mistake. I don't want you guys to make a mistake. All right, so I'm factorizing. So I'm multiplying through by negative 1 first. So now this becomes positive 3y squared, see right here, sir? This becomes negative 88y, see right here, sir? And this now becomes positive 484, see right here, sir? So when I multiply through that, I'm just pretty much flipping the negative sign. Remember, in each positive sign, there are 2 negative signs. So I'm just multiplying through by that in order to get my y squared term on the front. Sir, that's what we have been using all along. Yeah, that's why I want to be consistent and continue to use it. Fair enough?
Okay.
See where the 30 marks go.
I'm gonna reach now yet. So I'm factorizing this now. I'm factorizing this. Now you see, I'm multiplying this coefficient of y squared by the constant 484. So 484 times 3y is going to give me 1,452. And then I'm prime factorizing. So 2 into 1452 goes 726 times. 2 into 14 goes 7. 2 into 5 goes 2 times carry 1. 2 into 12 goes 6 times. Then I try 3 into 726. 3 into 7 goes. What? what? Sorry, it's actually 2. 2 into 7 goes 3 times, 2, 3, 6, carry 1, 2 into 12 goes 6, and 2 into 6 goes 3 times. Then I'm moving on to my next prime number. Can't be 2 because 2 is not divisible by 363 exactly, so I move on to 3. 3 into 1 into 3 goes 1 times, 3 into 6 goes 2 times, 3 into 3 goes 1 time. 4 can't work, well, 4 is not a prime number, 5 can't work, 6 is not prime, 7 can't work, 7 times 35, I want 36, no. 8 can't work because 8 is not prime, 9 is not prime, 10 is not prime, 11 is the next prime number that could work. And 11 into 121 goes 11 times. And I try 11 one more time, and 11 to 11 goes 1. This here's prime factorization. It works out much easier than you multiplying your A by your B and get some big numbers and frustrate yourself and frustrate me also in market. So that's how we get our values. Any questions?
Yes, so all right, so when you do the prime factorization, right? May I look on your arrows and your circles right there where it says that 2 times 11 and where it say 2 times 3 times 11. But I understand this one.
So what I have to do, Rash, is to manipulate my prime factors. I have to manipulate my prime factors until I can get what it is that I want. I want now a negative 100. I want a negative 88. I want a 1,452. But when I add my numbers, I'm supposed to get negative 88. That's what I want, negative 88. All right. Now, I would have to say, I'll have to say, what I'm saying is 2 times 11 is 22. This 22 here. And then 3 times 2 is 6, and 6 times 11 is 66. 66 plus 22 is 88. So therefore, when I multiply 22 by 66, I get 1,452.
Remember where the 1,452 come from again?
Multiply the coefficient of y squared by the constant. 3 times 484.
Oh, okay, cool. All right.
So I have found my factors. There's only one other thing. Them supposed to be negative because I want a negative 88 in the middle there. So, but when I multiply 2 negative numbers, I get a positive number. So it simply means then that my 22 is going to be negative, and so is my 66. So now add 22 to negative 66, and we get negative 88. Any questions?
This only happens when you have 3 components in the equation.
Say it again.
This only happens when you only have 3 components in the equation, sir.
No. Hold on. When you have to do the prime factorization?
Yes, sir.
Yes, when you get the quadratic equation in the form ax squared plus bx plus c. I don't have to be x, it could be ay squared plus by plus c.
Okay.
Good question.
Sir, can you go up, please?
Sure. Let me know when you finish. Talk, please. Are you okay? Talk to me, now, please. Can I move? Is anyone hearing me?
Yeah, man, sir.
Okay, you man, talk to me, now, man. All right. So I'm breaking up my negative 88 into negative 66y and negative 22y. So this negative 88 is being broken up into negative 66y and negative 22y. Then I'm going to group the first two in a one bracket, see right so. Leave the middle sign out every time, and the last two in the bracket, see so. Once there's a middle sign right here, so it says that the sign that is here, so they have to be flipped. Why, sir? Because in every positive number, there are two negative numbers here. You have one positive number here, so, but you have two negative numbers right here, so. So in every positive number, you have two negative numbers. Oh, so in every negative number of y, you have how many? No, in a word, so. All right, so let's go.
There's an invisible one outside the bracket.
Absolutely, absolutely. What is common here? That is, what is common here? That is common here. And one is a 3y, sir. I said, okay, good. What is left? Y. How you know, sir? When I multiply y by 3y, I'm going to get 3y squares, which is up here. And what is common here is going to be 22. Negative 22 times 3y is negative 66y. What is common here that is common there is going to be 22. 22 times y is 22y, and 22 times 22 is sorry, it's going to be 22. It's going to be 484. We're not going to multiply these two. Why, sir? Because whatsoever sign is in this parentheses here has to be the same sign in these other parentheses, or else you will not be able to factor it out as you did right here. So the two signs will have to be the same. And then this 3y comes what? So whatever is on the outside of the parentheses now forms a bracket. So this 3y comes right here, and this negative 22 goes right here. So either this term is equal to 0, or this year term is equal to 0. We need to check. If this year term is equal to 0, then we can have 3y equals 22. So y is going to be equal to 22 thirds. And if y minus 22 is equal to 0, it implies that y is equal to 22. Got me?
Yes, sir.
All right, do me a favor.
Sir, run back a little part there again.
Yeah. But before I do that, though, Rash, I'm gonna give you about 5 minutes to just look over this one. I'll come back and do the stuff. I'm gonna refresh myself, but I'm gonna come back and do this stuff because I'm speaking and I'm not even hearing anybody breathing because we're not muted the mic. And some of you,
Sir,
yeah,
a quick question, because I did check somebody.
a while ago, they might call upon you and you decide to say no answer. But anyhow,
Sir, the mic and my laptop I use, sir. I just realized that the mic I get trouble.
Conveniently. Go ahead, Papa.
All right, sir. So I did check with somebody yesterday, but then they say you could have also use the quadratic equation. I don't know if that's possible, sir.
It is. It is
Okay.
possible to use a quadratic formula to solve this part of the question.
Yeah, that part there, the person that showed me, so you could have used it for solve that part there up at the top there. So yeah.
EQUA. 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 Sure. So you could use a quadratic formula right here, and I put it here, y is equals to minus b plus or minus the square root of b squared minus 4 times a times c all over 2a. You could use it right here to solve, right? Why did I not use quadratic formula? It truth is, I've not used a quadratic formula with you for this course, let alone calculus 1. I've always used factorization, but if you understand the quadratic formula, you're good to go. I don't really use it because it's not my go-to formulation. But if you want, you could go ahead and use it. All right. So I'm going to give you a couple of minutes. Let me reduce this here. I'm going to give you a couple of minutes to look through that piece. Okay. Obviously, no rush. You see it now?
Oh, me?
Yeah.
Yeah, man, me catch the base part of my look on the scene.
Okay.
What me ask, sir, you can put a note right above where the cursor is blinking that says well at the part below it said grouping to give, right? Because you said when the sign outside is negative, the positive has to turn to negative because any negative to negative get positive. So that's why the 484 is positive and then it negative in the bracket, something like that. If you get what me I say.
I will.
Sir, why I delete that?
Because it just coming up my good something. Sure.
No,
No,
sir, you
man,
could
sir,
have
break
leave
the
it as
line.
it was.
Yeah, and break the
No.
line.
Everything as it was, sir.
No man, I'm gonna be nicer for you.
No, sir. So you know, stress yourself. You should have copied everything. Move it.
No man, I'm gonna be neat. I'm gonna put the I don't like the I tell you that of OCD and I don't believe me. You know. Honestly, when I really don't believe me. I want my document to look nice.
Sir, good night again. One question, sir. So the same way in which we cancel out the 2 with the 22 and to get the level, sir, would it be illegal if we cancel out the 4 with the 484 and stuff like that? If we use the same thing for the 4s?
Notice here though, you could cancel the 4 into the 484 and the 4 into the negative 44, but when you retry test, you'll have y squared over 4. So I keep saying,
Okay.
is it the
So
point?
that would make the difference. Yes, sir, and that's why.
Yeah, man.
Okay,
So
I just wanted to know.
yeah, man. So from about 2, this is separate and apart from what we're doing. This is just to kind of lengthen the class a little, so don't kill me on it. So about 3 paydays ago, I said to myself, I'm going to be splurging. I'm going to treat myself. I'm going to spoil myself. I'm going to go to either Burger King or I'm going to go to Wendy's and I'm going to buy me something very nice. And guess what? Since I'm going to be sitting, I'm just going to go to full 100 and buy milkshake to go with it. And on top of that, I just going to buy a pie and just or some cookies and just splurge. And every payday for the last 3 months, I drive by the place and look at it and say, oh, that is a sin, you know. And I keep driving by that. The last month, April gone, driving to Barbican and ready to go look for a park. And I said, oh God, I can't do it. And I just drive straight through the exit and go cover my yard. All right? Point I'm making is, if you're going to do that division, don't do it just halfway. Go to full 100. So don't, and I'm happy that you asked that question, Nikki, and make me like, they put it to you know, sir, it's going to be illegal. So what she's asking, sir, this 4 can be divided by 484. So can it be divided by the negative 44? Why never just divide that, sir? Is because I'm going to have y squared over 4. And it's going to interfere with my stuff still. So since it can't go full way, if I had a 4y here, or 8y or a 16y, yeah. But since I can't divide it fully, we just leave it. All right, just leave it. So if we can't eat, if you're gonna eat only half a burger, we're not gonna want a full burger. All right, let's go. I'll make that notation, Rash, that okay, so where I'm at now is
Make it fast, sir.
yeah, you can make it 5 here times.
Sir, question.
Mhm.
I just did test it to see if it work. I'm never really sure, but I actually get by the same answer that you have when we use the quadratic formula. Like how you have the, I just guess me did guess. I think you have a, oh you have a negative, yeah, would that be, B would that be negative 88. So is it a case where you would have, instead of it be minus, you would have made the 88 a positive? Or that correct, sir?
No, you have to keep it as negative.
Yeah, because you see, because you have this negative 88,
Yeah.
this sign, it has to be negative, because if you put that's positive, you have now changed the equation.
Okay.
Yeah, so it has to be negative 88.
All right, sir.
But then it's
Yeah.
gonna turn to positive 88,
No?
don't it, sir?
No, turn to positive 88.
When you have negative b,
Oh, yeah. Because you have negative times b. Yeah.
okay.
Very nice. What? Good. Let me carry out tonight.
So you want to carry me out to Wendy's?
I'm if I tell you, matter of fact, it'd be nice if all of us could have go when it's go sit down and just make them have to shut down the place. We just go to go make bully for knives and call police.
So I'm biggie box with a door, sir.
I'm if talk truth. Talk truth. Remember that. Remember when the negative sign forms, you're going to flip this sign above. I put the bracket here, but I want to sound bright, so I said parentheses. Same thing. Right? So remember, Rash, this is for you. So remember when a negative sign falls in the middle here, so you're going to flip the sign above, which is right up here, so right? Because both signs in the brackets, a 1 year and a 1 year, must be the same in order. In order to factorize.
Much respect.
No. So these are my two possible values of y. I must now substitute the values of y into a simplified equation. Now guess what? You see this? Equation 3 is my most simplified equation, so I'm going to use that. See right here, so this is my equation 3. So anyway, in equation 3, I see y, I'm going to put 22 over 3, and I'm going to do it again, and anywhere I see y, I'm going to put 22. So we have two values. So these are my critical values. So it says that I have two critical values of y. I'm going to end up with two critical points of y. But remember, the question says is a minimum one we want, not the maximum one. Right? Let's go. I'm going to do one and leave you to do the other one for me. So, and I'm going to do the difficult one. So I'm going to put y to be equal to 22 over 3 here. So see here, 22 minus y, 22 over 3, all over 2. I'm working my numerator. This 22 is 22 over 1. See it right here, so? Minus 22 over 3. The LCM here is now 3. 1 into 3 goes 3 times. 3 times 22 is 66. 3 into 3 goes 1 time. 1 times negative 22 is negative 22. 66 minus 44 minus 22 is equal to 44. Follow me? And then 2 times 3 is equal to 6. All right, so I'm going to get, and then 44 divided by 6 is going to be equal to 22 over 3. So I still come back up with the 22 over 3. Sir, it will work out like that all the time? Absolutely not. Absolutely not. Look at this. Try substituting y equals 22 into here, so, and tell me what you get.
Here, sir.
Duh, very good. Take a minute and look through this calculation here. This one is the most difficult one. So take a minute and look through that for me, please.
Sir, why the two come back here somewhere? Oh, because I didn't do one. So even though the 2 is the denominator, now why the 3?
Hmm?
The 3,
Mhm.
why the 3 goes back to the denominator?
All right. And it's just how I did the question.
Because you use the LCM.
Because remember the LCM is 3, so I have to put the LCM down here also.
Okay.
Because
Alright.
if you just imagine that I don't have this 2 right here, so let's forget about this 2 right here, so and I'm going to do this thing. 66 divided by 3 is 22. See the 22 here, so, or better yet, up here, so. And then minus 22 divided by 3, see here, so, minus 22 over 3. But remember, you're going to have a 2 in the denominator right here, so. The one here, so. So is it right here, so. So that's why I get the 326 right here, so. Yes, I mean, you can do it any way you want to do it. And you're correct. 22 minus 22 is 0, so I'm going to have x equals to 22 thirds, or x is equal to 0. So watch me. When x is equal to 22 over 3, y is also equal to 22 over 3. And when x is equal to 0, y equals 22. You know, need to classify the coordinates. You need to classify the coordinates. See here, so that's a formulation. This is a formulation to classify the coordinates. F of x times f of y minus f of xy all squares. Or if you want to write, you can put f of yx all squares, no matter which one of them you use, because both of them need to be the same thing, same function it comes out to be. All right? F of x. Oh, sir, I see what you say. No. Sir, you say you couldn't tell whether or not f of x equals positive because you have a y value here. So, sir, if you put in a y value here, no, sir, we can't see if it is positive or negative. Amen. Yes. But, sir, you expect it to be positive, don't? Watch this. So, what I did was the easy one first, 0.22, which is this, 0.22, and 22 thirds, comma 22 thirds, which is this here. So, watch me. 0.22 is going to be y is equal to 22. 2 times 22 is equal to 44. See it right here, sir? What is x? I mean, y. Remember, x is 0, and also 2 times 0 is 0. So that's why this comes 0. And xy. X is 0, so that goes to 0. Minus 22 plus 2y, but y are 22. So this is 2 times 22 is just 44. 44 minus 22 and 22. That's how this gets from 22. All right? So this is this. So let us check here, so now. We're not do that one yet. F of xx, 44, times f of yy, 0, minus f of xy or yx all squares. All right? So I'm going to end up with 22 squares. 44 times 0 is 0. And 22 squares is going to be 484. So my d is going to be negative 484. Oh. But sir, when d is negative, you don't have a minimum, sir. When d is negative, you have a saddle point. So am I interested in this point? 0.22?
No.
Tell me why no.
Any question that asks a minimum operator.
Very good. Very good. The question asks me to minimize. The question asks me to minimize. So since the question asks me to minimize, I can't go use a saddle point because a saddle point is not a minimum point. All right. So I have to go through the other stuff. Can I use that one? Question asks me to minimize. So let's go. F of xx. We need to work with this part. F of xx. 2 times y. So I'm going to be 44 over 3. See it right here, so. 2 times x, 44 over 3 again. See it right here, so. It's going to be 44 over 3 minus 22 plus 44 over 3. 44 over 3 plus 44 over 3 is going to be 88 over 3. 88 over 3 minus 22 is going to be 22 over 3. No. Trust me on these calculations. Now we need to substitute that into the formula. F of xx, 44 thirds, see it right here, so. times f of y 44 thirds again, see right here, so minus f of xy all squares, 22 over 3 all squares, see right here, so 44 times 44 is 1936, and 3 times 3 is 9. I will already calculate what 22 squares is 484, and 3 squares equals to 9. Trust me. When I do this calculation here, we get this to be positive. 1452 over 9. Uh-oh. But sir, when D is positive, it says that we have either relative maximum or relative minimum. Then we need to look at our f of xx. See here, f of xx is a positive number. That means I have a relative minimum. So the points that I'm interested in will be 22 over 3 and 22 over 3. That's 100% positive. Listen, that was something more in. Okay, but at the morning 30 marks, so that's fine. Question.
This
Habla.
could give you 60 marks.
Exactly. Exactly.
Oh, goodness.
30 marks are really long.
30 marks to just shell my brain out. So better this just be the entire exam alone and done.
That means that I would have wasted.
Agreed.
I would have wasted my time from whenever. Oh Lord, what did I do? I'd have wasted my time going through. It's so long. It's a long time I use crisscross, and it's a TikTok dance. Penis.
Wait, sir.
See me so. See me so, Sash. See? Crisscross. Hey. Yeah, man. Teacher.
So that's
You're the plan. Let us stick to the calculus 2 here. We will get through better. Hey, no, you want to see me dance? And me and Charlene have to go up on the dance floor.
Charlie, come in.
Charlene, you can dance?
Sarah put on dancing long time, say.
Boy, I just imagine all Lexan and German have 2 left foot and them can't dance to save them life. Where is Yannick? Oh, shit. Wait. Oh. Okay. Rather quiet. TT, you all right?
Good night, sir.
Good night, honey.
Yes, sir.
All right, nice. Hi, Davio. Talking to me tonight? Davio, one again.
Hi, sir.
Okay, good night, honey bunches. All right. Have you boy good?
Yes, sir.
Understanding, hon?
Yes, sir.
Nice. Alrighty then. 834. This is the hardest that I've seen them get at it. I have 20 to 26 minutes. 2x squared plus 2xy plus 3y squared. 2x squared. Right, this is another question. 2012. 2x squared plus 2xy. All right, teachers, now watch this. 2010. May 2010. 2x squared plus 2xy plus 3y squared minus 16x minus 18y plus 54. 2x squared plus 2xy minus 3. 16. You recognize it's the same function? Anybody?
Yes, sir.
So 2010 and 2012 paper, question repeated. And I put it there because I wanted to highlight the point that it is repeated. All right, I have just one more past paper question. Let's have one more past paper question, and this is it. I'm giving you 20 minutes. Crazy. I'm giving you 15 minutes. When you're looking at past paper, you can tell me how many marks this was. So I can all right. 15 minutes. Let me bigify it. Sean, Ramesh, pay attention and start working. On the mark, let's go. Anybody finish the 6 differentiations?
Yeah,
Yes,
man.
sir.
All right. You want me to show you them now, so at least you know that you're on the right track?
Sure.
Sure.
See them there? And again, the question says to minimize. All right, so this is a point I'm making here. You see of xx is positive, no matter what the critical value is, because it's a whole number. All right, continue working. Hurry up.
Sir, check the chat. Sir.
Sir,
Yes, Papa.
you can check the chat as well too.
All right. I'm checking, but let me see what is happening. How many times am I logged in? I'm logged in twice. That's the problem. So the conversation is
20 minimum.
it's going to the other. Hold on. It's going to the other. Whoa. And you're talking on one thing, but it's going to the other. Okay. All right, Nikki, see that? All right, Rush, you and Nikki get the same thing.
Bullet!
I don't know if it's right, but you and Nikki get the same thing.
I want to see Yannick get it, man. If I want to see Yannick get the same thing right, man.
Okay. Right. All right, come. 2 more minutes.
There's a no comment.
Oh, I was gonna, when I said 2 more minutes, I was actually gonna be moving here to project something here. So let me reduction it. So I want to explain to me how you get the 20 now.
Sir.
Hold on, let's sir. My dad press the talk, sorry.
Nikki, can we talk to me? Tell me how you get the 20.
Who, me?
No, Anika. Nikki? Woo! Miss M. All right. Nikki not talk to me. Tell me how you get the 20.
Who, me?
Yeah.
Why, sir? Method of elimination use up at the top and come down, you know. But me see I have 4x plus y square equal 16. So you carry it over. I never do that.
No, because I'm making two equations.
You see,
Simultaneously.
see the part the second equation you have times minus 2 times minus 2. Oh, it's supposed to be add?
It depends on what you're doing.
Why say me do the elimination different from how you do it, you know?
We can private chat then 10 minutes.
All right, no problem.
The elimination way different.
Sir, I did the elimination different too, but I did the same answer, sir. But you still don't tell me, Mama, get tell you right or wrong, say myself.
So I'm asking you how you got the 20. That's what I'm asking. But you weren't
Okay,
answering me.
sir. So wait. Okay, so I'm put in the for the fxx. For the fxx, when you get 4, I'm gonna put in that times the fyy.
Oh, is this 20 talking about?
Yeah.
Yes, sir. What
Yes.
I say to that? Yes, sir. That's the 20, sir.
Sir, man. Sir.
You know, and some kids, sir, and let me have.
I love it. I love it. I love it.
Sir, you make man they are afraid. But fun and joke aside, sir, I do the elimination way different, you know, because what I did is that me times the top one by 2 and the bottom one by 4. Right? And then me subtract the equations from the one another. Subtract the equation, sorry, and then I find y and x and then continue.
Okay. All right. So no, I follow the conversation because not just you, but quite a number of you, ABC got everything. What am I telling you? When you understand something, you know, you can't get to time, you know. X equals 3, y equals 2, d is 3,2 equals 20, and the church goer too. Whoa, church goer. I love it. I love it.
So, sir, one last thing. All right. Your d equals to 3, 2. And that may have seen.
That's you know, you have to have that. That's a critical point. Ryan Campbell, can you unmute for me, please, sir?
And that may have. Sir, my critical point -7 and 30.
A timely reminder. I met a beautiful soul recently. I don't have to ask you for number. I can just take my phone and just send a message. Just say, what you do, Ryan? You not talk to me in a class. Talk to me. What happened?
Wait. I'll review it and make a note, sir. Or may I keep track for the most part?
You know, like bus for my virgin them, you know. Don't make my bus for you, you know.
Oh, sir, very good, boy. Be safe.
All right, make sure. All right, cool. Yes, Rash, you're saying something about what you don't get the 3,2?
No, sir. When I get that. When I get that there one, sir. I guess based on home we do the elimination why we get y equal -7 and x equal 30.
Let me ask. Nikki, you got the 3,2 for the critical point?
Yes, sir.
All right, cool.
I want me do wrong then.
I don't have a clue. But I forgot to check it because for 30 marks, we don't want to get piece of the answer. And then we end up getting 15 out of the 30. Remember no, you know why I was saying no at first? Let me just explain why I was saying no at first. Because when I say, remember, you know, I don't know how many of you recall me saying this. I am not interested in what this works out to be. This is this 20 that I have here. I don't know if anybody remembers when I say I'm not interested in that 20. I'm just interested whether it is positive or negative. Anybody remember me saying that in class?
Yes, sir.
What I'm interested in is my critical point or points. I'm very interested in my critical point or points. But when I'm classifying the nature of the critical points, I am not interested in the actual value. What I'm interested in is what sign it has. If it's positive, if it is negative, if it equals to 0. Because each of those things will give me the nature of the critical point. It's like an investigation, you know. You go to the doctor, you're running a fever, all right? You're running a fever. What's the fever? Reading 102. Serious, you can get into shock. What is causing the fever? And doctor check and say, no, something is causing the fever. Something is causing the fever. and he will do a process of elimination, and until he gets to the source of what is happening. Pretty much a similar thing that we have been doing right here. Pretty similar. All right. So you see it now, Rash, where you went wrong? Talk to me. 3 minutes past 9. I have to move on. Talk to me. Are you seeing it now?
Kinda.
Let's go. So you're not seeing. All right. So did you get these as your equations?
Yeah.
And you set it equals to 0?
Yeah.
And you have the
realize what you're doing, sir. You carry over the 2 negative over the equal sign and turn it to a positive, and then you multiply by 2 negative 2 down on the base. Yeah, so I'm gonna say that part there.
All right. What it is saying to me is we are having some challenge with simultaneous equation, and I suspect it's not you alone. I suspect it's not you alone. Anyhow, it's 4 minutes past 9. Ready for the mid-semester now?
You say you just teach out all of them study, so.
Truth.
Háblame. So wait, anybody not answer me?
Sir, you didn't even say you teach out all of them study.
Talk of youth.
What am I supposed to do? Talk to me now, tell me what to do.
Give it to us as FBA, sir.
Yes, sir, make it be a take home work. I will submit over the weekend or something.
That's unfair enough.
Praise the Lord.
Amen.
Amen.
This is too close to the Sabbath
Praise him.
for your need to be sinning. Way too close to the Sabbath.
No, but sir, Ayani said, well, sir.
That's the point I'm making.
I Sabbath person say it, you know.
Sir, that's why I say Sunday.
And I'm saying to you, it is too close to your Sabbath to be sinning.
Sir, I said that can't work.
Absolutely, Karika. Tell him to me.
Sir, I don't see why it can't work though.
Sir, me I sin, sir. Sir, let me read that. Yes, sir.
A while ago, you just told me some, the normal man of the road speak the Jamaican vernacular in a different form. You just put it in, yes.
Sir, out of where me say and out of what going in a chat, me closer to the gate of heaven,
Me know, but guess what? Me did it, me don't know who in front of who, but me did it too.
Me I check the book, for let you in.
No, that one is funny.
Jesus. But a good thing about a man of the book class, you must say, he say, are you're not coming in the place. So talk to me. Let me know. Okay, so first things first.
Sir, I just talk to you,
Yeah, I'm here, But guess what? That is null and void. So we can move on to the next best suggestion.
Anything goes, sir.
Anything goes. Oh, thank you, Mr. Lexon. I'll talk Wednesday.
Sir, sorry, is it my Wi-Fi went out? So what are we talking about? The test? Okay, sir. So we're going to get it now.
That's my plan. But your very loving colleagues are
Sir, how long is the test? Because my eyes I used to pick all of them.
Okay. Let me just one more something. See? Make sure safe.
Sir, I can't promise I will be available for next week, Thursday.
Nobody can get me. It's so long with this supposed to as well. And it's favor. By the way, we're going next week Thursday. Talk to me.
So you realize that most Thursday I'm not at class. So I have other stuff doing. So I reach home very, very late.
Oh, really? Mm-hmm.
Yes, sir.
Yeah, but go talk to me. So make sure reach home
So
early.
everybody have to get the test one time.
Mm-hmm. All right, no, guys. Like on a serious note. What time is it now? 10 past. All right, I am ready. I have been ready. People have been prepared for quite a while. If it is not done tonight, it has to be done on Tuesday. So people have to go reach home in time to get it done on Tuesday.
Sir, Tuesday I'm gonna leave work till 7:30, so I'm gonna know all that possible.
Right. So. Sean Anderson, unmute for me, please.
Sir, so give it Sunday. Anybody objecting to doing it on Sunday?
Yeah, it's Sunday, you know.
No, Sunday again.
Kerika. Tuesday is the other option. You can do it as Tuesday.
Sunday, sir.
Sean Anderson.
Wait, never mind. Sunday don't work for me. Just remember Sunday I work Sunday.
No, we're not on Sunday. No class on Sunday.
I work on Sunday, sir. So 1 o'clock. I don't leave work until 5 on Sunday.
Okay.
So Sunday night I can't work then, man. Since I leave work 5.
I am stating my position. Everybody else have to pitch in, so we know where I work with. Because somebody said 1.
Sir, how long is the test?
No, man, make it after make it in the evening.
So we're not just do it in the next class?
Excuse me, madam.
Yep.
But I won't be at class early for that.
Oh, it's a 5 o'clock class, no?
It's a 5 o'clock class. Yeah, that's why every time we miss it, I keep putting it on for Thursday.
Sir, Sunday night is good, sir.
Okay, but let me tell you what is happening. I still have 1 or 2 stuff to go through, and it's very important because really and truly, you know, I would love if I can do the test outside of class, so I can just go on teach a thing or two because I still have. Let me stop share something here.
Sure, I don't want to cut it, but I would really like if every individual raise their opinion so we can settle on the best mark.
All right, so since we are the director of elections,
go ahead.
If we don't see agreeing for everybody who agree with Sunday night.
Sunday night.
Anytime after 5 when we need reach.
Raise your hand.
The question the green or the razor or something.
Oh, you do that again.
Ryan.
See it there.
Yes, sir.
Remember that Miss has a scheduler class for us on Sunday.
I'm sorry.
No, it's not. This is not this Sunday.
Oh, it's not
Sunday
this
is not
Sunday.
the 16th.
No. We're talking about calculus right now.
So we have 1, 2, 3, 4, 5. Alton and Lexton say yes.
Ryan,
put up your hand now. People put up your hand.
Elections, you know, we work with anything. Alton say, Alton, are you my own person?
I'm good for Sunday night.
All right, sir. Sunday night it is.
Okay, all right, no problem. Let's continue.
Majority speak.
What about Davia? Does Sunday work for you, Davia?
You know, never put up around. And Tiana, let's see Tiana and Opaida.
TT Goodman.
Okay. Davis, Davis there.
Time Sunday after 6, right?
Yeah. After that. We don't cook on them Sunday. Because it's Sunday Mother's Day, you know.
Yeah, man.
At 2.
Well, we can just zoom.
We have about 9 mother.
All right. All right.
All right, so take long for cook. So.
Boy, if you plan to carry out to no matter, just pay feeding and make them go and go eat.
No, which is right.
Jesus, effort in you. Oh, Lord help me. All right, come, let's go. All right. So Sunday it is then.
Yes, sir.
All things considered.
Sunday 6, right?
After them times there. All things considered.
Yeah. Anytime after 5, that we need to give unique time for each one. 1 second.
Anytime after 6. Anytime after 6.
Yeah. So Sarah can just note that in the group.
All right, no problem. All right. This is it, you know, I can't find any other past paper question. I've looked in the past papers and I have seen only a few of those, and all that I've seen I have typed out and I have done. And so let me see. Oh no, sorry. I needed to do something with you. Let me share that screen. Oh no. Hold on. The question said, determine how much would be spent on each year to minimize this cost. So you found the 20 here, which is going to be the minimum. So therefore, the critical point is given as 3,2. So it implies that 3 million was spent on labor, while 2 million is spent on automated equipment. Because X represents the amount spent on labor, and Y is the amount spent on automated equipment. So Y is the automated equipment. So it's going to be 2 million for Y for automated. What is saying automotive? Automated equipment, Lord Jesus, more so you can know. And $3 million for labor, because it did say both in millions of dollars. All right. And then what is the minimum cost? You see this part here? This part as -20 is showing us that indeed we got a relative minimum. Man them said to you, the minimum cost.
Where is -20, sir?
Not -20, +20.
Oh.
That's a -20 a while ago?
Yeah.
Oh,
Big
sorry.
size, sir. Okay.
It's +20. And then now it is asking us the minimum. What is the minimum cost? You know it's a minimum cost because the values were minimum. It's not a maximum at all. I'm sure you know how to read a question enough. When you look at the something, if they had asked you to find a maximum cost or determine how much should be spent on each year to maximize this cost, it would have been, you'd have had to get a maximum value. You'd have had to get a maximum value. And in this case, the critical point is just 1. So if when you got the critical point and you work it out and you got a relative maximum, the question couldn't work because it asks you for the minimum cost. Never ask for a maximum cost. So in your headspace, as you work in the question, you know, you know what it is that you're supposed to be getting. So it gives you an idea as to where you're going, which is what is important. All right. I'm going to give you. I was about to say I'm going to give you 2 minutes to just look in the past papers to see if you'll find anything else, and I don't think I want to do that. I don't think I want to do that. What I want to do is I want to talk to you about. I just go through this one question and then oh Lord, that one is long. So is that one? All right. Let me go through this one. This is also another question that that could also be a must-have. I know this I said could also be a must-have. They don't always give it.
So this is like chemistry.
But when they do, them come hard. come really, really hard. By the way, Sean Anderson never asked to unmute a while ago, boy.
So repeat that.
Never asked to unmute a while ago.
I did. So.
What you do?
Oh, okay.
All right.
Yes, sir.
You need to call me after class here.
My phone's not working, sir.
Okay. All right, no problem. So since the phone not working, I can call you on the phone?
Oh, no, sir.
I was just being ridiculous a while ago. I was just being ridiculous. You say phone not working, so if I call you now, we can get you after one is good for me. Okay. All right. Oh no, okay. You see, Nico? Hey, Krishna, you're the next one to, you know, talk to me anytime, you know, Krishna. Mr. Arnold. And Mr. Yeah, right. Just try to make sure to say the day here. All right, good. Lagrange multipliers. This is one of the last, not the last, but one of the last heavy topics that we need to look at. My aim is to see if I can finish off by sometime next week. And so it is that we can start working some past papers. And we can work those past papers and work them and work them and work them and work them. And need to see some A's this semester. So that's the aim. That's the aim of mine, to finish off beforehand so we can work papers before the 24th. You recognize that the timetable was fixed, so no exam on the 23rd. It's confirmed. I had confirmed it before, but it's fully confirmed now. Trust me. I want to finish off by next week, so that final week, on the good to go. We're not have a soon, if we don't have problems, don't call me. But we're supposed to be fully ready for the exam. So we can just take class, we can just work. All right, let's go. So in this section, we're going to take a look at another way of optimizing a function. So what it is that we just did a while ago was optimization. And as I explained to you, anybody ever used the term optimization before?
So that's why I asked you what the topic was, because I thought it was optimization.
Yeah. It is multivariable functions, but what it is that we're looking at is optimization. So for example, says really, I answered you correctly now. So for example, you know, let me just say from now. You see this topic, SI matrix, is on your syllabus. And I've never seen anybody set an exam question on it before. And I'm saying to myself, but if you not teach it, I bet at that time everyone will go sit it on the paper. So I'm going to need to, you know, because the same second partial derivative that we've been working with. But I've never seen a question. So you can go in the past papers, and you're not going to see a question on it. I've never in the years.
Why they want strength, sir?
I don't know, but I've never seen. I always teach it, you know, because I don't want the students to go into the exam and see it and can't do it. But I've never seen a question on it. All right, let's go. So the annual labor cost and material cost for a company's production of computers is given by that multivariable function. So it says to find the total cost if in a given year the company spends $1 million on labor and $3 million on material. Do you recognize that all you have to do here lies? That's a different question. No, it's the same question, but the man then put in this piece. So let me just do this piece with you. So them say find the total cost if in a given year the company spends $1 million on labor and $3 million on team. Yes, Ryan. We are seeing Ryan. And it's unfair. You cannot.
So it was deliberate.
I mean, no, it is unfair, and it looked like one East Indian too, you know.
There's a Julie. Share them.
You eating Julie? All right. Forgive me, Jesus. All right, let's go. So it says find the total cost if in a given year the company spends $1 million on labor and $3 million on material. Now remember, labor is X and material is Y. So anywhere you see X, you put 1, and anywhere you see Y, you put 3. See there? X are 1 and Y are 3. So the company is going to spend $90 million. The company didn't spend $19 million. All right. So this question is really on, and you would have done the other parts of the question before to get the 20 and to get the 3-2 and to relative minimum, right? So the question is on optimization because the company now, based on what it is that they would have done, is to come up with a formulation. This formulation, now them knows, so here the plan. The formulation is what defines my profit. Is what optimizes my operation, right? It means that I'll be operating at an optimum, right? Sometimes like what happened to me the other day, I'm trying to send out some stuff to you on some notes, and then it says to me that my phone is full. I was like, oh, the phone is full. And I look at the stuff, I said, oh Lord, all of these WhatsApp messages come, yes, and I know I can set the phone so that I can make the messages disappear and I don't have to save the stuff, but everything that comes to the phone gets saved. So I had to be going through and just deleting some of the stuff that I kind of have an interest in and others I don't have no affiliation with. So I just delete those until I delete about a gigabyte worth of foolishness. All right, and then the phone becomes operable again. It means that I have caused my phone to be working at an optimum at this point in time. When it full again, I'm going to optimize it. So this is just one form of optimization. All right. Nobody goes into a business to make a loss, but they will have to do what it is that they have to do in order to recognize what needs to be done. And case in point, places like KFC and Wendy's and Popeyes, even Tasties too. Next thing you think I'm talking about the foreign companies. They all have their formulation for the manufacturing of their products. Devon House. So which is why when Devon House, well, Devon House is not a good example because they may just get the buckets of ice cream and just serve it from the different locations. But when you're talking about a place that prepares a meal, right? Wendy's, Popeyes, KFC, Burger King, there is a particular standard. They know what to put in that, how much to put in that, in order to get that chicken done. Matter of fact, saw a documentary where no one person has a formulation for KFC. The formulation comes in pieces. So Ryan have piece, Charlene have piece, Sasha have piece, Andrew have piece, and that's how they put it in piece. Just like when you go into the bank to work, no one person has the code to get into the bank. The teller supervisor and the other persons, you may have 3 people or 4 people who will have to put in a sequence of codes in order to get that ball open. So if you hold me up, members say you're not gonna get no money. And you kill me, you're still not gonna get no money. So better not hurt me. Because you're not gonna get no money. It means that I have to call all parties, so all parties can put in their information to get the vault open. That's exactly what we're doing right here. All right. So Lagrange multiply is another form of optimization that we need to spend a little bit of time on. And you know how I run my show already. I'm not going to keep it for much longer since you don't want the test tonight. But what I want to do is just to give an explanation and maybe just to look at the first part of the question. All right. So it says this optimization is going to be subjected to a constraint, right? The constraint is going to be given. Now, if it's in today's day, the constraint will be COVID. That will be the constraint, COVID. Oh boy. I needed had a fit the other day. Go to the gas station as I normally would and say to the attendant, fill me up. You want to top up, bossy? I say, yeah, top it up, but not top it up, make it the gas touch the rim or something. Yeah. And when we hear the youth, I put the nozzle back into the pump as I'm finished fill up the car. And I glance at the stuff. It's $13,000. And let me tell you something. If you tell me it's $13,000 before, but I tell you it's $15,000 and drag over my business. It is rough. And today, gas went up to about $4.20 or thereabout more. Sir, where you going? You see those people at PCJ? They are trying to optimize, get the best value. So everybody's going to talk about Ukraine and Russia war. Every single, and you will talk about now the United States of America is actually using their reserves and they're not sending their reserves to any country because they want the reserve for themselves. Yeah, that part is true too. But the constraint.
Man about Ukraine war and gas price.
Oh?
Uncat man.
Talk truth. No man, it's rough, man. It's not. Let me tell you something. It is one of the roughest periods. I have lived through what people would say one of the roughest periods in our Jamaican history. And slowly but surely, this is going to be this is slowly and surely becoming the second roughest, if not going to be the roughest period in our history. Rough. Sound like a chihuahua a while ago, but trust me, rough. So the constraint is going to be, in this case, the pandemic. So I was saying to you, Mr. KFC guy, he came up with a formulation. No one person has it. That's the man's money. That's the man's money. So what happened is that it's a franchise. So you will have consistency with the taste. So they say. Because trust me, I've had KFC in America and it don't taste no way like the KFC in Jamaica or Jamaican KFC at the boss. Right? And similarly, I've been to the States where I go to Wendy's and say, you know, may I have a baked potato with broccoli and sprinkle a little bit of bacon on top of that? Say, excuse me? Baked potato. Oh no, we don't do that. So I say this to say to you that our Jamaican menu is fitting the culture of Jamaica. When you go to Wendy's in Curacao, they may have lizard or frog. One of them something there they may have as a delicacy there because this is their culture, right? So the constraint is going to be whatever you make it to be, all right? So the constraint or constraints may be the equation or equations described by the boundary of the region of a region, although in this section we will not concentrate on those types of problems, since the method just requires a general constraint and does not really care where the strong constraint comes from. So let us get things set up. We want to optimize, that is to find the minimum or maximum value of a function, f of x of y, subject to the constraint g of x of y, which is equal to k. All right, so remember, when we're optimizing, we're actually finding the maximum or the minimum. All right, again, the constraint may be the equation that describes the boundary of a region, or it may not be. The process is actually fairly simple, although the work can still be a little overwhelming at times, which is true. So you see the last calculation I just gave you a while ago, that's the most difficult calculation. No, not that last one. The one with the 22 over something and the 0 and the 22. That was the most difficult question on this topic that I've seen in the past papers. And if you look at it, it's really not that difficult to know. It's just that it requires a little bit more energy out of you. But it is solvable. It is solvable. All right? So these companies sometimes they pay hefty money in order to get the formulation for the stuff. And in the formulation, trust me, them would build in a miscellaneous cost, you know. So it is lucrative to the proprietor of the business. And that formulation is going to go close to your heart. Now, if I want to find out any information about your optimization, either a maximum or a minimum, I just go directly to that formulation. I don't have to start from scratch. All right? Let's go. So it says find the maximum and minimum of f of xy is equal to 5x minus 3y, subject to the constraint x squared plus y squared equals 136. All right? Watch me now. You notice here, what the fact? Do you understand what I just talked about up top already, guys? Are you with me?
Yes.
Yes, sir.
All right, so let's go. I was about to say that, you know, let us call it a night, but let me just do this first part, because when I'm going through this next class, we will be in a better position. So see my function here, 5x minus 3y. Look at what is happening. I'm calling this 5, and I'm going to say that it is equals to 2 lambda x. 5 is going to be equals to 2 lambda x. And my negative 3 is going to be equals to 2 lambda y. Right? My question to you is that how did we arrive at these equations? Note, lambda is going to be the Lagrange multiplier. See the constraint here, x squared plus y squared is equal to 136. X squared plus y squared is equal to 136. So let us investigate the differentials. Lambda cannot be equal to 0, straight up. If lambda is equal to 0, it means that we cannot optimize the whole question itself. So lambda cannot be equal to 0. So we're going to solve the first two equations by of x and y respectively. Watch this. My x is going to be equal to 5 over 2 lambda. My y is going to be equal to negative 3 over 2 lambda, which is here. This is a reason for lambda not being able to equal to 0 also. It can't have a 0 in the denominator. Does not exist. All right? And remember, lambda is a Lagrange multiplier. All right? So that's another reason. Plugging these into the constraints. Now remember, we're going to be doing a bit of substitution, and we're using a constraint now because this is pretty much a limit of what it is that we're doing. All right? So when we substitute these into the constraint, this is going to become 5 over 2 lambda squares, because it's x squared, plus negative 3 over 2 lambda all squares equals to 136. So it's what I've done. I've used my equation to get it in the form of lambda into x and y. And then I'm substituting it to my constraint. So this is going to become 5 squared. This is very similar to what it is that we have been doing. 5 times 25 over 2, so it's going to be 4 lambda squares. This is going to be positive 9 over 4 lambda squares equals to 136. When the denominators are the same, you add them, you put it back and add the numerator. 29 plus 4 is 30, 29 plus 5 is 34. So we have 34 over lambda squares. 4 lambda squares is equal to this 136. Remember, when you have two fractions separated by an equal sign, you always cross multiply. 34 times 1 is 34. And 4 lambda squares times 136 is going to give me 544 lambda squared. My aim is to find lambda. I have an equation with one unknown. I need to find this unknown. So I divide both sides by 544. So we have lambda squares is equal to all of that. Once I find the square root, it gives me my answer. So lambda is going to be equal to plus or minus. When I divide 34 into 500 and 544, I get 1 over 16. So 1 over 16 is equal to lambda squared. And I don't want lambda
That's to
squared.
be a fraction, sir.
Right. I don't want lambda. Yeah, don't leave it as a decimal. You notice, sir, never normally leave this stuff as a decimal. Always try to leave it as a fraction. The only time I leave it as a decimal is unless it can't be converted to a fraction. And then what I'm going to do now is I'm going to have lambda to be equals to +4, or a positive a quarter, I'm sorry, or negative a quarter. Remember, when we take the square root of a number, it's a positive root that we take as well as a negative root. All right. And then I could do it. Let me just do this part. So the first part here, we know the value of lambda. So lambda has two values. Lambda has one which is positive 1/4, and the other one it is negative 1/4. So why did you get 2, sir? I would only get lambda equals a quarter. But remember, when you find the square root of a number, you also get the positive root as well as a negative root. Because when you multiply negative a quarter by negative a quarter, you're going to end up with a positive number. And when you multiply positive a quarter by positive a quarter, you're going to end up with the same number as when you multiply the two negative numbers together. All right, very important. I know you know that too. But recall, my x was equal to this lambda, my y was equal to this lambda. So since I have a value of lambda in the first instance, which is a quarter, anywhere in all of this I see lambda, I'm going to put a quarter. So I get x equals to 10 right here. I do the same thing here, so. And x, see it right here, so x is going to be -6. So therefore, I don't want to say critical point, but if you want to think of it like that, it now becomes 10, -6, which is what we have been doing. All right. Similarly, when it's equals to negative a quarter, we're going to substitute it in nonetheless, and we're going to get -10, +6. All right. So you're going to think of these as critical points, but they are not. Think of them as critical points, but they are not. Similar to what we have studied in single and multivariable functions previously. Now, to determine if we have a maximum or minimum, we just pump these into the function, plug them back into the function. So we're going to look at -10, 6. -10, 6, so put it in this function here. And it's 5 times -10 minus 3 times -6, no, +6, and I get a negative value. All right. Now, this value here is negative. You notice I said that is a minimum, and I substitute it in here. So this value here is a positive, and I'm saying to you that is a maximum. We excluded lambda equals 0 because it would not solve one of the or more of the equations. Do not always expect this to happen. Sometimes you will be able to automatically exclude a value of lambda, and sometimes you will not be able to do it. And that's all that there is to Lagrange multiplier. I mean, I know that I went through this very quickly. If you don't get it, it's not a problem. I just needed to go through that. So, and I will send this off to you so that when next we meet, at least we have a framework from which to operate. Let me say this before we say our goodbyes. I'm at the last piece of it. I have SI matrix to look at. I have some double integrations to look at. And I have some more of these Lagrange multipliers to look at with you. SI matrix, I can use one of the 3 all sessions to start and finish. And the double integration, you already know how to integrate. Double integration, I can do that also. I get a general feel that some of you are struggling, but not saying anything. Some of you are struggling and not saying anything. Now, I'm going to make this appeal. For those of you who are having a challenge, do not sit down and walla into your despair. Find a classmate who can. You see, I am opting not to be a part of this in the initial stage because it's the same way I explain it to you, it's the same way I'm going to come and talk to you. But your classmate may have a different way of explaining and you may see it seamlessly. Start working from now. When I press equal on my calculator, I'm supposed to see a grade greater than 50%, so I can say yes, then pass the course. Secondly, the traction for 80% is not going. Beloved, you know, I mean, I want to close out the assessment for you know, because it means if I close out the assessment, you know, someone will get fail the exam. So I'm going to ask of you to start working and complete your assessments online. Please. Please and thanks. Finally, the amount of time that I have put off in mid-semester for one reason or another, and make sure so now you capitalize on this opportunity so that the lowest grade I can possibly get when I mark those papers will be 80%. Real talk. Real talk. And then you complete your 80% of assignments and you get another 80% on that, for the most pass the course. So those are the three things that I wanted to talk to you about. To whom much is given, of him or her much is expected. I know some of you are working, but my talk is more for those who have been pussyfooting around, coming to class and doing assignments and just getting ready. All right. I'm going to take a 5 and then I send this thing off. Continue to do well. Pick up yourself. Say drink for Jesus. Start studying. Any questions? If not, later.
Well, I say one question.
Go ahead, Papa.
Do you know when we'll be able to get the final draft? Because I need to set a date by Tuesday in my support meeting, so we can take that day off. I'm gonna see it on the 27th. So is there a possibility that it might change again?
Yeah, so there is going to be just one more draft that is going to be final. I really can't tell you, Rash, because what they do is CCCJ will give us like maybe like a week, so it is that the information can be posted so that students can, you know, let them know which exam is missing versus which time is versus whatever else, whatever housekeeping matters, that information that CCCJ gets, because they do get it. So when sometimes when you see, like if you look at the timetable that I send you, and incidentally, you know, I'm not over here, that the timetables that I send you, it has different color codes, yellow and green, and then say the yellow ones, yeah, whatever them say, the yellow ones were amended and the green ones were never added to the timetable. Because you know, sometimes things can happen and they leave off a course. So like for us, they left off a course first, and I told them from the first draft, and I'm not seeing the course for the second draft. So I sent an email again, because I think the last one that is going to be coming is going to say final draft. And I want those students to be able to do their exam. So yes, I can't tell you just now. Not even exams will be able to tell you just now when.
Kind of put me in a sticky situation, but
yeah.
Anywhere between anywhere in the next week should be good before we
Anyway,
can make
next
the
week?
date. Yes.
So guess what? I'm suspecting. Let me just check on something here. Yeah, man. It has to come up by next. It has to come up by next week, because the following week would be the study break, well, quote unquote, their study break. So I would say by Friday the 13th, the other draft should come out. And as soon as it come out, as I have been doing, I'll send it off.
Okay, cool.
That's all. Take care, guys.
Not yet, sir. Sir,
Oh, go ahead,
sir, my
honey.
always like 3 hours ago. Sir, 2 things. One, sir, the YouTube. May I beg you, please.
Yeah, I hear you.
Please, sir, please.
I hear you. I did request help. I did request help in getting this stuff. Let me just let me follow through on that. Yeah, man. Let me follow through on that. I know you're not the only one that has been asking. I got some private messages, and yeah, so I'll work on that for you. What's the second one?
What? That's number 2. It's just McLaren's Newton Ramsden and small change coming on the mid semester, right?
Newton Ramsden, small change, something like that. Yeah.
Just unit 1, sir, in other words.
Just unit 1. Yeah, it's unit 1. Yeah, that's what I was trying to remember. All of unit 1 is coming.
Okay. Okay.
All right.
So just make sure you go through your unit 1 and you should be good to go.
Feel good then. Feel good.
Yeah, man. Number 3, Jan?
All right. So it don't make no sense for coming pan headache or stuff. So
Please don't. Just go finish your work on it, all right? Love you know later. Take care.
All right, sir. Much
Yeah,
respect.
bless your heart. Bless up.